In this video, we're going to look at dividing rational expressions, and the big thing to remember when you're dividing two fractions is the second fraction gets flipped over, and then you multiply instead of divide. And there's a lot of background on that, but hopefully you're kind of aware of that. If you have any questions, of course, you can review rules of division. But remember, if you have like 2/3 divided by 3/8, that's equal to 2/3 multiplied by the reciprocal of the 3/8, 8/3. So that idea holds for dividing rational expressions. So the first thing we'll do is flip the second fraction over, and that would give us 9x to the 5th divided by 8y squared times 16y to the 9th over 3x. We can now check for common factors, and I see that I have some x's in common to both the numerator and denominator. So I'm going to divide out 1x, which will leave me an exponent of 4 in the numerator. And then I'm going to divide out 2y's, which will leave me 9 minus 2 would be 7 in the numerator. And now I'm going to check for my coefficients. My coefficients have a 9 in the numerator, so that will be a 3 dividing with the 3 in the denominator, which will leave me a 1. 8 and 16 also have a factor of 8 in common, so I'm going to divide the 8 out and get 1, divide the 16 by 8 and get 2. So now I just rewrite it, multiplying everything out. 3 times 2 is 6, x to the 4th, y to the 7th, all over 1 times 1 times 1 times 1. So it's all ones in the denominator. When you multiply 1 together, you just get 1. And so my final answer actually doesn't need to be written as a fraction. It can be written as just 6 x to the 4th, y to the 7th. First, I'm going to flip my second fraction over and turn it into a multiplication. So I have 5y minus 5x over 15y cubed multiplied to the reciprocal, 3x plus 3y all over x squared minus y squared. Now, the next thing to do is find greatest common factors, and I can see a few. I'm also going to factor this difference of two squares. I'll have an x plus y and an x minus y in the second denominator. I'm also going to factor a 3 out of that same numerator, so I'll have 3 times the quantity x plus y. I'll also look at the first numerator, factoring out a 5. And now I have everything factored, and I can start reducing the common factors. I have a y minus x and an x minus y. From previously, we know we can factor out a negative if we do that. So instead of making that too complicated, I'm actually going to factor the negative out of the numerator just because it's easier to work with that way, and turn that to an opposite sign. Now I can reduce it with what's in the denominator. Negative y plus x is the same as x minus y, so I can divide those out. I have a 3 and a 15, that'll give me a 5 remaining. I have a negative 5 and a positive 5, so those will reduce out. But before I do that, I'm also going to reduce this x plus y and this x plus y here. So I'll be left with a negative 1 in the numerator, and both my 5's will divide out as well. These are quite reducible. They become quite simple. So finally, all I'm left with is a negative 1 y cubed. So I have the y cubed is in the denominator, the negative 1 is in the numerator. For part C, on part C, we're going to flip the second fraction over. That gives us y squared minus 36 over y squared minus 8y plus 16 times y squared in the numerator minus y minus 12 over 3y minus 18. Now we need to factor this. In the numerator we'll have a y plus 6 and a y minus 6. In the denominator we will have a y and a y. I need to figure out how to get a negative 8y and a positive 16. We could do negative 4, negative 4. That would give us what we need. In the second fraction we have y squared minus y minus 12. That's a difference of 1, so we'll have y minus 4y plus 3. And then lastly, I'm going to factor the denominator. We have a GCF, or greatest common factor, of 3, so we'll have 3y minus 6. So the y minus 6 is grouped separately. I can rewrite this with all my factors listed out. Y plus 6, y minus 6, y minus 4, y plus 3, all divided by y minus 4 times y minus 4 times 3 times y minus 6. And now I just divide out the common factors. I look for anything with a y plus 6. There isn't. Y minus 6 has a common factor in the denominator, so I divide that out. Y minus 4 has a common factor, and y plus 3 does not. So we're left with the final answer, y plus 6 times y plus 3 all over y minus 4 times 3. And we could FOIL it out or distribute and multiply together, or not. I'm fine with you leaving it in this form here. So we're going to combine multiplication and division into one exercise. And you may recall PEMDAS, or PEMDAS, whatever way you pronounce it. But it's parentheses, it's an acronym representing parentheses, exponents, and then multiplication and division in order from left to right, and addition and subtraction in order from left to right. So in this case, we are working on that process. So we work our way from left to right, and anywhere that there is a division, we flip it over, and then it becomes a multiplication. So in this case, we only have one division fraction. So I'm just going to rewrite all the fractions, flipping over the fractions that directly follow a division sign. From here, I need to factor each fraction. So that's what I'm going to do next. My first fraction has a 4x squared minus 9y squared in the numerator. So I'm going to factor that to a 2x and a minus 3y and a 2x plus 3y. The denominator on the first fraction is an 8x cubed minus 27y cubed. This is a difference of cubes, so I know I'll have a binomial factor and a trinomial factor. I'll have a 2x minus 3y, a 4x squared, a positive 6xy, and a positive 9y squared. For my second fraction, I have 3x minus 9y. I'll factor out a 3 and I'll have x minus 3y as the binomial. I have a 4x plus 6y in the denominator. Factoring out a 2, I'll have 2x plus 3y. For my last fraction, I have 4x squared plus 6xy plus 9y squared, and that just conveniently matches the trinomial factor of my difference of cubes. So I'm just going to rewrite that because it will divide out here in a minute. In the denominator, I need to factor the 4x squared minus 8xy plus 3y squared. This will factor to 2x plus 3y, 2x minus 3y, and 2x minus y. We can double check that by multiplying the outer and the inner, finding their product, and adding them together. This will give me a negative 6xy and a negative 2xy. Now that I know those work, I'm going to start reducing all the factors, anything that's equivalent to 1. So I start on the left side in the numerator and check for matching fractions in the denominator. 2x minus 3y has a common factor in the denominator, so I cross that out. 2x plus 3y has a common factor in the denominator, so I cross that out. 3 does not have a common factor in the denominator, so I skip it. X minus 3y does not have a common factor in the denominator, so I skip it. 4x squared plus 6y xy plus 9y squared has a factor in the denominator, so I reduce it out. And I have now checked all the factors in the numerator, so I'm good to go. Everything that's remaining is now a remaining fraction factor that will not reduce. So that will give me 3 times x minus 3y all over 2 times 2x minus 3y, and that multiplied to 2x minus y. Now you could multiply these out again, but I am completely fine with you leaving them in factored form.